them two more hydrochloric acid. Solid method magnesium glucose. Solution N, D-sodium hydroxide. With an alkaline indicator, we are required to the rate of reaction between hydrochloric acid and magnesium glucose. Molarity of solution N. The relative atomic mass of X in sodium hydroxide ion. Procedure 1. Measure 20 centimeter cubic of 2 mole hydrochloric acid into a plastic beaker. Cut the magnesium glucose into 6 pieces, each of 1.5 centimeter. Place 1 piece of magnesium glucose into the beaker with the acid and immediately start the stopwatch. Note the time taken for the magnesium to react completely and record it in table 1. Pour out the content of the beaker and rinse it with distilled water followed by a little of hydrochloric acid. Measure 16 centimeter cubic of the 2 mole of hydrochloric acid and add 4 centimeter cubic of distilled water. Shake and add the second piece of magnesium glucose and start the stopwatch immediately. Record the time taken for the magnesium to react completely with the acid in table 1. Repeat the procedure 4 and 5 above using the volumes of acid and water as shown in the table.
So as per the procedure, you have the magnesium ribbon. This magnesium ribbon has been cleaned, or has been the coating of magnesium oxide has been removed by scrubbing until it becomes shiny. And we have already cut 2 pieces of the ribbon. We have these 2 pieces. These are the ones we are going to use for the experiment. We are going to perform only 2 experiments. We have got data values that we are going to use for the remaining part of the experiment. So the first experiment, we are going to measure 20 cubic centimeters of hydrochloric acid, 2 moles hydrochloric acid. So we measure 20, this is hydrochloric acid and this is water. So we measure exactly 20 cubic centimeters like this. So we pour it down like this. So it is very close to the point. So that is the point. We stop there. And then for the next experiment, we are going to measure 16 cubic centimeters of hydrochloric acid, which is this one. So we have 20, we add 16, we stop at 36. So we drop it like this. So almost 36. So the first portion, we are not going to add anything, we leave it like that. This is 20 cubic centimeters. The second portion, we are going to add 4 cubic centimeters of distilled water to make it up to 20. That's exactly 4 cubic centimeters. So for this one that we have added water, 4 cubic centimeters of water, we must shake like this. The reason for shaking is to obtain a homogeneous solution. So this portion has been diluted, the other one has not been diluted. So this is for experiment 2 and this is for experiment 1. This ribbon, this is 1.5 centimeter ribbon and this is the stopwatch, it is at 0. We drop the 2 at the same time. So when the experiment ends, we'll stop the stopwatch. So immediately focus. So when the magnesium produce no more bubbles or is all consumed, we'll stop the experiment. So we do the timing like that. It's almost over. It is less concentrated than the first portion. You want to see how many seconds will it take, or how much time is it going to take for the reaction to reach completion. So we are going to drop. We are going to drop and start at the same time. So, focus it there. We see the time it will take for it to reach completion. Where do you stop?
Yeah.
E. Okay. When it is over, from our experiment, are shown 27 for the first one, whereby we added no water. The second one, where we added 4 cubic centimeters of distilled water to 16 cubic centimeters of hydrochloric acid. The time taken is 38 seconds. The third one, 12 cubic centimeters of hydrochloric acid and 8 cubic centimeters of distilled water, 56 seconds. The third one, 8 cubic centimeters of 2 molar hydrochloric acid. We add 12 cubic centimeters of distilled water. We got 70 seconds. And the last one is 4 cubic centimeters of 2 molar hydrochloric acid and 16 cubic centimeters of distilled water. When adding the ribbon, it took only 150 cubic centimeters. We want now to calculate the rate of the reaction, which is 100 divided by time. So for the first one, we'll have 1,000, we divide by 27, whereby we'll get that 7.03. So instead of writing that 7.03, we'll write that is 7. What is that? Values that you have got, the time that you have got. These are the values obtained for the rates. 1,000 divided by 27, we get that 7. 1,000 divided by 38, we get that 6. 1,000 divided by 56, we get 18. 1,000 divided by 70, we get 14. 1,000 divided by 150, we get 7. Now, we have got the following marking points. The first marking point is the complete table. This one scores 1 mark. So if the table is completely filled, we have 1 mark. And then the accuracy mark. For us to get the accuracy mark, it is pegged on the first value, the first time. So the time, if the school value is 27 for the first value, that is this value here, then it is plus or minus 2. So any student who gets 29 or any student who gets 25, between 25 and 29 will get the accuracy mark, which is going to be a half a mark. So 25, 26, 27, 28 and 29, all these students will be able to get a half a mark for the accuracy mark. The next mark is the decimal point mark. Now the decimal point mark will be obtained if the student has not used any decimal point. Like in this case, no student has used we have not used any decimal point here. So all the values must be the same. They must be consistent. So decimal point, if there's no decimal point, then we do what? We give the student a mark, which is actually a half a mark. Or if the student has decided to put the values to 1 decimal point, then the values must be the same. Like for example, for the rate, if it is 37.0, 26.0, 18.0, 14.0, 7.0, then all of them have been filled to 1 decimal place. Therefore, the student gets the decimal point. It doesn't matter if the student has not put any value on the upper values, that's for the time, has not put any decimal, but has put on the second. But if the student commits to put a decimal on the upper values, that is to 1 decimal place like this, then all the values must be to 1 decimal place. So that is 27.0, 38.0, 56.0, 70.0, and then 150.0. The decimal point must be visible. The student must commit to to make sure that the decimal is visible like this. The student must commit to make sure the decimal point is visible. So the student may use one decimal place in the upper side, and on the lower side he uses two decimal places. So if you decide to make this one 2, then all of them must be 2. So that one a 0 there, a 0 here, a 0 here, and a 0 here. So the decimal point is a half. The last, our marks are supposed to be 3. So already we have 2 marks. We have seen how we are going to get the 2 marks. So the last mark is for the trend. As per what we are having here, as we decrease the concentration by increasing the volume of water, what we have noted is that the time increases. So the table for time must be what? Must be increasing as we are moving across. But the table for rate must be decreasing. So time to increase, rate to decrease. Of rate, which is per second, against volume of 2 molar hydrochloric acid, which is in cubic centimeters. So we have to label the axis. So the first one is the x-axis, which will be containing volume in cubic centimeters, and rate is on the y-axis, which is per second. So the volume in cubic centimeters will be plotted using these values. The first value is 4. So the lowest value is 4 and the highest value is 20. So we'll start from 0, which is at this point. So here is 0 and here is also 0. So we have got 2 origins for the x and the y axis. So if we take here, while we are plotting, there's a scale mark. That scale mark is usually cut if you use 3/4 of the graph paper. So we are going to count the number of squares. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these 15 squares, we calculate 3/4 of the 15 squares. So 3/4 of 15 is 3 divided by 4, which is equals to 3 divided by 4, which is equals to 0.75. We multiply by 15. So on this side, we should use at least 11 squares. That is on the x-axis. On the x-axis, we need at least 11 squares. And then on the y-axis, we have the following number of boxes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 boxes. So we calculate 3/4 of 12 boxes, which is going to be at least 9 boxes. So what will we do? If we take on the side of volume, the lower value is 4, the higher value is 20. So now, if we take 5, 5, so 5, 10, 15, 20. So the whole of our graph will be this side. So that is a poor scale. If we take at least 2 boxes to be 5, so you'll have 5, 10, 15, 20. It will go up to this, up to here. These are how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. That is still less. So if we take 3 to be 5, 3 boxes, 3 big boxes, that is 1, 2, 3. So it will be 5, 10, 15, and then 20. This is not badly off. So we are going to take that scale. So here we'll have 5, and then 10, and then 15, and then 20. And then what? 25? 25. On the y-axis, the rate begins at 7 and ends at 37. So if you have this as 0, and then we count. Let us take this to be 5, so it will be 5, 10, 15, 20, 25, 25, 30, 35. These are how many boxes? 1, 2, 3, 4, 5, 6, 7. Okay? Let's say two boxes to be 15. That will still be smaller. Because if two boxes were 10 and still it was small, then it means we have got to add. But let us take just the one for 5, we just use it to see what is going to happen. So we'll have here 0, and then 5, and then 10, and then 15, and then 16, and then 17, 18, 19, 20, sorry, 5, 10, 15, after 15 it is what? 20. After 20, 25, after 25, 30, we make the correction, 30, after 30, 35, after that 5, 40. That is not badly off. The highest is 37, that's why I'm stopping at 40 here. But in case of anything, we are going to extend. It's going to be 45, it's going to be 50, this is going to be 55, and this one is going to be 60. So we extend like that. So at volume 20, the rate is 37. So here is 20. The rate is 37. So here is 35. So each one is 1. 35, that's 6, that's 7. So we make a cross here. The only mark accepted is a cross. We do not accept any other mark. So that's a cross. The next is 16, 26. So this is 15 and this is 20. That we have obtained. We are going to join these plots using a line of best fit, which should be going through the origin. That is going through 0. So we look for the line of best fit with at least 2 points. This one is not bad. We have these 2 points, this one, and they are going through the origin. We can try these other ones. We see if we are having 2 which are going through the origin. Let us see these 2. They are not going through the origin. These 2 are not going through the origin. The only 2 which are going through the origin are these 2. So this one and this one. So what do? We draw a straight line and you extend it like that. 3 points have been left out. We'll assume that. Now, let us see the marking of this particular table. There's a mark for the plots. So these plots must be correct. Like for example, the first plot is supposed to be 20, that's 7. So the teacher comes and checks if truly when the volume is 20, you have indicated that 7, even if they are outside the straight line. So for the rest, the same will be done, considering the values that you have on the table. So the plot mark is 1. The next one is the labeling mark. Labeling of the axis. The labeling of the axis, volume in cubic centimeters, rate per second. So you should be having the parameter and the unit of measurement. The parameter here is volume and the unit is cubic centimeters. The rate, the other parameter here is rate and the unit is per second. So that is how we draw the graph. So the labeling of the axis, if you have indicated the 2, volume, cubic centimeters, rate per second, you get 1 mark. 1 mark. And then the other mark is for the scale. Now the scale is if you have used 3/4 in this side and 3/4 in this side, and then you have drawn the line. Okay? Very well. So a simple way of knowing whether your scale is correct is just folding the paper like this. And then into half, and then into quarter, like this. After folding, you open it. And then you see if part of the student's work is in this square, a part of it is in this square, and a part of it is in the upper square. So if all of them, if these squares, if part of the work is up here, a part of it is down here, part of it is on this side, and a part of it is in this other side, then the student scores 1 mark for the scale. Lastly, we have a last mark which is for the line. Okay, the line. We have said we draw the line of best fit with at least 2 points, two plots on the line, which should be going through the origin. And I hope you have been keen enough to realize that the origin, there's the origin for the x-axis and there's the origin for the y-axis. So if it is 0, we should be having 2 zeros, one for the x-axis and the other one for the y-axis. Now we go to the questions. The first question, use the graph to determine the time taken for 2 cubic centimeter length of magnesium ribbon. For our case, it was not 2 centimeters, but it was 1.5 centimeters. Okay, the time taken for 1.5 centimeter length of magnesium ribbon to completely react with 10 cubic centimeters of 2 molar hydrochloric acid. So what will you do? We'll come to where the volume is 10. We interpolate like this. You start from 10, you go to where we have the line, like this. On reaching the line, you extrapolate. So the interpolation line and extrapolation line must be visible, like this. So the first marking point is the interpolation and extrapolation line. So if this one is not there, then you are not going to the questions. Then, what do? We read. This is 15, 16, 17. This 17 is very close to 18. So you can say it is 17.75. So the answer there is 17.75 per second. Seconds. This is per second. 17.75 per second. But the question is what? Time. Not what? Rate. What was our rate? Our rate was 1000 divided by time. And then our answer for our rate is 17.75. So we calculate this t. We find the value of t. So our t will be 17.75. We divide by, 1000 divided by 17.75. So we press the calculator and we see the answer we are going to get. So this is 1000. We divide by 17.75, which is going to be 56.34 seconds. 56.34 seconds. That's how we have got that 56. First interpolation, extrapolation. Read. After reading, you write the reading on the question. After getting the reading, you now know that that reading was obtained by dividing 1000 by time. So you get the value of time by equating. 1000 divided by time is equal to 17.75. The second part of the question, the rate of reaction when 15 cubic centimeters of 2 molar hydrochloric acid was used. So we go to 15, that is 15, this is 15. We interpolate like this. After interpolating, we extrapolate like this. So in extrapolating, we read. So this is exactly rate. So there's no calculation you are going to make. What will you do? We just go directly and read. This is 25. So this is 26. And it is very close again to 26. So it is what? 25.75. So the answer we get here is 25.75 rate. The unit is per second. So you write here per second like this. I hope you are very keen with the first question up here. It was requiring time. Therefore, we indicated first of all the rate, and then we use the rate to calculate time. Last question. State the relationship between rate of reaction and the concentration of the acid. So we come here and we see concentration is high when the volume of the 2 molar hydrochloric acid is high. That is when we add less water. So when it is 20, the rate is high. When the volume was decreased to about 5, the rate is low. So what does that tell us? Rate of reaction decreases with decrease in concentration. So you can write it the first way. We say rate of reaction decreases with decrease in concentration. Okay, that is the relationship. That relationship is the same as this. When the volume of the acid was low, that is when the concentration was low, the rate was low. When the volume of the acid is high, the rate is high. So what does that tell us? It means rate of reaction increases with increase in concentration of the acid. So you can also write that one. It implies the same as the first statement, which is rate increases with increase in concentration, which is still the same as rate of reaction is directly proportional to concentration. So you can say the rate of reaction is directly proportional to concentration. I hope we are keen enough to realize that we have written 3 statements which mean the same thing. So the student should not cram the first, the second, and the third. If a student writes the first one, he gets 1 mark. If the student writes the second one, he gets the same 1 mark. And if the student writes the last statement, he still gets the same 1 mark. We stop there. Let's meet in our next video.